Hello guys, how are you today? So today it is Sunday, June 8th, 2025, and I'll be explaining the last Math AMS of grade 10, which is the Math AMS of term 3, week 10. How cool is that? How wonderful is that? For a full year, I've been explaining the Math AMSs like a full academic year, and I'm so happy I was able to do this. And I'm so happy to have you guys, my viewers. I consider you as my students. So thank you for watching. And anyways, I'm gonna get on with the final explanation of the last Math AMS of grade 10. So the first and second terms of a geometric progression are 1 over 10 and 7 over 2 respectively. What is the common ratio of this progression? When we're dealing with a geometric progression, in order to find the common ratio, we will have to divide the second term from the first term, or not, we can take it as second divided by first, or the next divided by the previous. So for example, in this case, we have the first and second terms. So what is the next term? The next term is 7 over 2 divided by the first term, or the previous term, which is 1 over 10. Now, I prefer you write it like this on your calculator because this will reduce any mistakes. So 7 over 2, then you will put the divided sign 1 over 10, and you're supposed to get an answer of what? An answer of 35. So the first and second terms of geometric progression, 1 over 10, 7 over 2, their common ratio is 35 because we did second term divided by the first term. We move on to question number 2. Which of the following is a factor of 45x squared plus 20 over the set of complex numbers? Now, there's many ways to solve this. If you have the option on your calculator, you can do mod 5, 3. Okay, so if you do mod 5, 3, then in part A, so you have A, B, and C. In part A, you would put 45. Part B, you're gonna put 0 because you don't have anything in part B. And part C, you would put 20. Why? Because usually it's in the form of ax squared plus bx plus c. What we have given over here is ax squared, so we have a. We don't have bx, so we will replace it with 0, and we have c, which is 20. So we could put it like this on our calculator. If we did put it like this, we would get that x is equal to 2 over 3i. This is one of the roots. And then the second one, x is equal to minus 2 over 3i. But since they want what? Do they want the roots or they want the factors? They want the factors. In order for us to find the value of the factors, we will have to move 3 to the other side. So if it was division, then it's going to become multiplication. So now 3x is equal to 2i, and then 3x is equal to minus 2i, and then you will move 2i to the other side. So now you will get what? You will get that 3x minus 2i is one factor, and here it's minus 2i, don't forget about this. And another factor is what it is, 3x plus 2i. So we found the first factor, 3x minus 2i, and the second factor, 3x plus 2i. Now, if you don't have this option on your calculator, how will we be able to solve this? Personally, how I would like to do it is I would like to take the common factor. I would like to factorize this on its own. Take the common factor out. If you take it out, you're going to be left with 5, which is the common factor, multiplied by 9x squared plus 4. Notice here we have what? We have a square and we have a square, but we don't have a minus. If we had a minus, we could do the difference of 2 squares. We could do dots, the difference of 2 squares. But we have a plus, not a minus. So how I would solve this personally is like I would imagine there is no plus, and I would deal with it as if it were a difference of 2 squares. If I did this method and I factorized it, I would get 3x minus 2, 3x plus 2. Now here's the important part. Because we have plus instead of minus, we don't have minus, we have plus, what we're going to do is next to the constant number, what's the constant number in this case? It's minus 2 and plus 2. You are going to put an I next to it. So very simply, you got the factors. You have the first factor, 3x minus 2i, and the second factor, 3x plus 2i. And do not forget the 5 that you have outside. So the factor, 3x minus 2i, 3x plus 2i. Now, after factorizing it, if you remember, it was what? It was 5, 3x minus 2i, 3x plus 2i. So very simply, 5, 3x plus 2i, 3x plus minus 2i. Okay? We move on to question number 3. Which of the following is equivalent to the given expression whenever x is greater than 3? So here they did not tell us that we need to find what is the condition for it to be a rational or like something logical, for it to actually make sense mathematically. They gave it to us. They gave it the expression that makes it logical mathematically. But what we need to do is we need to find the simplified version. So how do we do this? We need to factorize everything. So how do we factorize everything? We first start with this. Let's factorize this. You can take out 3. It will be 3x minus 3 over this one. You guys should know how to factorize by now. You should know how to do the product sum. If you don't want to do the product sum, you can do mod 5, 3, okay? When you do mod 5, 3, for A, you're going to put 1, for B, you're going to put 3, and for C, you're going to put minus 10, and you will get x is equal to 2, and x is equal to minus 5. So x equals 2, x equals minus 5. Move them to the other side, you get x minus 2 times x plus 5. So these are the two factors, x minus 2, x plus 5. You should know how to do the product sum method, by the way. Times. For the top one, it's the same way, but you're supposed to get x minus 3 and x plus 5. You should factorize it. You should know how to factorize it. And then for the final one, you're supposed to get x minus 3 and then x minus 2. So just like that, we factorized everything possible. Now what we need to do is we need to cancel out. You can cancel out what? You can cancel out the numerator with the denominator. What does this mean? This means x minus 3, you can cancel it with x minus 3. You could also do it like this. You can do x minus 3, x minus 3. You can also remove x plus 5, x plus 5. But you cannot cancel this because they are both in the denominator. Now finally, after you simplify it, you're supposed to get an answer of 3x minus 9 over x minus 2 squared. So 3x minus 9 over x minus 2 squared. That means this is our answer. Okay, we'll move on to question number 4. It says the first term of a geometric progression is 48 and the second term is 36. In simplest form, the common ratio of a progression. How to find the common ratio of a progression? Very simply, you will do the second term over the first term. Or it could be the next term divided by the previous term. So in this case, what is the next term or the second term? It is 36 divided by the first term or the previous term, which is 48. 36 divided by 48 will give us an answer of what? Of 3 over 4. So very simply, in simplest form, the common ratio of this progression is 3 over 4. Now the sum to infinity of this series. How do we find the sum to infinity of this series? Very simply, to find the sum of infinity, it is g1 over 1 minus r. Now, how do we know if something converges or diverges? In order to know if the sum to infinity will converge or diverge, we have to look at the ratio r. If r, the absolute value of r, is greater than 1, then you will know that it diverges. However, if the absolute value of r is less than 1, then you will know that it converges. We did not take if it equals to 1, so for now, keep out of your mind if it equals to 1, okay? So in this case, because our ratio, the absolute value of our ratio is less than 1, then we will know it's converging. If it's converging, that means it's going to give us a number bigger than the first term. So the first term, which was 48 for us, you're going to divide it by 1 minus the ratio, which is 3 over 4. Put it on your calculator. 48 over 1 minus 3 over 4, you're going to get an answer of 192. So the sum to infinity of this series is 192, very simply. Okay, we move on to to question number 5. The first three terms of a geometric sequence or geometric progression are 5, 5m, and 30m. They want to find the value of m and the common ratio. So what do you need to know? You need to know that common ratio is equal to what? To the second term or the next term divided by the first term. So in this case, you have 5m over 5. It could give us what? It could give us the common ratio. But what could also give us the common ratio? We can also find the common ratio by doing what? By doing 30m over 5m. So this will give us the common ratio and this will also give us the common ratio. But which one will give us a whole number as an answer? This will give us, not a whole number, sorry, as a number, which will give us a number as an answer. This will give us a number as an answer. So we found what? That the value of the common ratio is 6. So remember, that the value of the common ratio r, it's gonna be the next term divided by the first term, or second divided by the first, okay? Now, 5m over 5 is equal to the common ratio. We found that the common ratio is equal to 6, right? We found it by doing next term over previous term. So now that we have the common ratio r, we can be able to find the value of m. So 5m over 5 is equal to the common ratio r. Cancel 5 and 5. You will be left with m is equal to r. Okay, so we know that r, the common ratio is 6. That means m is also equal to 6. This is one way of doing it. Another way of doing it is what? Is to find the common ratio by doing 30m over 5m is equal to what? Is equal to 5m over 5. And you will be able to find what? You'll be able to find the value of m. Why? Because 30m over 5m will give us value of common ratio, and 5m over 5 will also give us value of common ratio. So this will be 6. 6 is equal to 5m over 5. So then 6 is equal to m. As you can see, it's the exact same answer. So m is 6 and the common ratio is 6. But as you can see, since the common ratio is greater than 1, the absolute value of the common ratio is greater than 1, so the sum to infinity of the given progression diverges. However, if it was less than 1, if the absolute value was less than 1, then it will converge. The first two terms of an arithmetic progression, pay attention, arithmetic progression are minus 7 and 1. What do we mean by arithmetic progression? That means we are constantly adding by a number, or there is what? A common difference. So, how do we solve this? Very simply, how I would solve this is I would first find the common difference. How do we find the common difference? Given two terms, you're going to do the term after, which is 1. You will subtract it from the term before, so minus 7. 1 minus 7, you can do it on the calculator, you can do it mentally, it will give you an answer of 8. Okay, so now that we have our common difference d, which is 8, we will be able to find the next 5 terms of this progression. You could do it either by finding the equation, so one way is by finding the equation, or the other way, which is much easier, is just by adding 8 every time. What does this mean? This means to find the next 5 terms, you're going to do what? You're going to add 8, so 1 plus 8 is 9, and then you're going to add 8 again, 9 plus 8 is 17, and then again, 8 plus 17 is 25, and then you will add 8 again, you will get 33, and then again you will add 8 to get 41. Now we can count how many times we did it. This is time 1, time 2, time 3, time 4, and time 5. Just like that, we found the next 5 terms. In order, they are 9, 17, 25, 33, and 41. Remember, you just keep on adding 8, plus 8, plus 8, plus 8, plus 8, plus 8. So, in order, the terms are 9, 17, 25, 33, and 41. So that is it for question number 6. We move on to question number 7. It seems my internet is glitching a bit. Here we go. Now my timer restarted, but it's fine. Okay. A is an arithmetic progression with first term A1 minus 15, and common difference d is equal to 6. Okay, so first stop everything. First, is this an arithmetic or a geometric sequence? It's an arithmetic progression, or arithmetic progression or arithmetic sequence. So how do we find the values using the arithmetic progression? You have to find the equation. What's the general rule or the general equation? It is an is equal to a1 plus n minus 1 times d. Okay? So, very simply in this case, an, which is a9, is equal, I wrote aq, a9 is equal to a1, which is minus 15, plus n minus 1, we're dealing with 9, so 9 minus 1 times the common difference, which is 6. Put it on your calculator. What answer are you going to get? So, minus 15 plus 9 minus 1 times 6, it's going to give us an answer of 33. That means, very simply, a9 is equal to 33. Now, what if we were dealing with a101? Then it's going to be a101 is equal to a1, which is minus 15, plus 101 minus 1 times what? Times 6. Okay? So, if we put it on the calculator, it's going to be minus 15 plus 101 minus 1 times 6. So, it will give us an answer of what? Of 585. So we have value of a9 is 33, value of A101 is 585. Okay, so the value of A9 is 33 and the value of A101 is 585. We move on to the next question. It says B is an arithmetic progression with first term B1 is equal to 9, second term B2 is equal to 17. What is the sum of the first 20 terms of the progression B? Look what we have. First of all, we have B1, which is the first term. Then we have B2, which is the second term. Using these two, because it's an arithmetic progression, we'll be able to find what? We'll be able to find the common difference. So common difference D is equal to B2 minus B1. So 17 minus 9, which is 8. So now the common difference D is equal to 8. Okay? Now, what is the sum of the first 20 terms of the progression B? There is many ways on how to do this, but personally, my favorite way, or how I prefer to do it, is by using the equation n over 2 times a1 plus an. In order to use this, we will need to find an. What is n? N is 20. So let us find an. An is equal to what? An is equal to a1 plus n minus 1 times d. So a1 is 9 plus 20 minus 1 times the common difference d, which is what? Which is 8. So 9 plus 20 minus 1 times 8, you're going to get 161. So now we have what? We have an and we have a1. So we will be able to find what? To find the sum of the first 20 terms. So it's going to be 20 over 2, so n over 2, 20 over 2, times a1, which is 9, plus an, which is 161. So putting it on the calculator, you're supposed to get an answer of 1700 or 1700. So very simply, the answer is 1700. We'll move on to question number 9. What is the value of the common difference of the given arithmetic series? So how do we find the common difference knowing it's an arithmetic series or an arithmetic progression? What we need to do is take any two terms. For example, this one, this is first term, second term, or second term, third term, or whatever, any two consecutive terms, and subtract them. So you could do what? You could do 9 minus 4 equals to 5, 4 minus 1 equals to 5, minus 1 minus 6 equals to 5. They're all going to give you the same answer, which is what? Which is 5. So the common difference is 5. Now, what is the value of the sum above? How do we find the value of the sum above? Again, as I said, the value of sum for arithmetic series, my personal favorite way of using it is what? Is n over 2 times a1 plus an. So let us together find the value of n, because we have a1, which is minus 6, and we have an, which is 239. So let us find the n together. Okay, in order to find n, what we will need to do is apply the equation an is equal to a1 times n minus 1 times d. An is what? Is 239. Is equal to a1. What is a1? a1 is minus 6 times plus n minus 1 times the common difference d. What's the common difference d? We found it to be 5. So move this to the other side. It becomes 239 plus 6, which will become 245. Now 245 is equal to n minus 1 times 5. Divide both sides by 5. You will be left with 49 is equal to n minus 1. Bring it to the other side, n is equal to 50. Now that we have the value of n, we will be able to find the sum by applying this equation. So n, which is 50, over 2, times a1, which is minus 6, plus an, which is 239. Put it on the calculator. Minus 6 plus 239. It will give us an answer of what? An answer of 5825. So very simply, the answer is 5825. We move on to question number 10. Okay, here it seems like a difficult question, but it's very easy. A conference hall has 14 rows of seats. This is n because for each row of seats, for each row, you have a different number of seats. But look, there are 10 seats in the first row and 88 seats in the last row. Each row exceeds the previous one by the same number of seats. What does this mean? That means it has a common difference d. If it has a common difference d, then this is an arithmetic progression. They want to find how many seats are there in the conference hall in total, meaning they need the sum. To find the sum, we use the equation n over 2 times a1 plus an. What does this mean? This means we have 14 rows. First row, a1 is 10 seats. Last row, an is 88 seats. So substitute everything, you will find your answer. Very simply, it's going to be 14 over 2 times a1, which is 10, plus an, which is 88. Put it on the calculator. And you're supposed to get an answer of 686. So in the whole conference hall, there is 686 seats. Okay, we move on to question number 11. Now, here there is many ways of doing it, but I will do it in my personal favorite way. So, use the fact that the sum of the first k integers is k plus 1 over 2 to answer the following question. And what is the value of b? What is the value of c? Okay, they want us to basically find a general equation for the sum. So how could you do this? And how could I do this? How could we do this in a way? There's actually two ways to do this. You could use it, you could do the, you could use this way, which is n over 2 times 2a plus n minus 1 times d. You could do this way, which you will get the same answer. But personally, how I would like to do it is, I would like to use what is given. They gave us what? They gave us 9m minus 2, right? So we have 9m minus 2. And they gave us that the sum of the first k integers is k times k plus 1 over 2. Now, pay attention. Take out the 9m minus 2. 9m minus 2. This does not exist anymore. You will totally forget that this exists. Okay? So, 9m minus 2. What do you notice? You notice that the 9 has a variable, whereas the 2 does not have a variable. So what we're going to do in this case is we're going to substitute this. But I don't like using k integers. I like to use n integers. So what you're going to do is just replace the k by n. So look how it is. If you need to find the sum of the first n integers, remember, always the equation for the sum, or not the equation, sorry. The sum of the first integers is usually what? N times n plus 1 over 2. Always, always it will be this. Okay, so this is very, very important to remember. Okay, so n times n plus 1 over 2. Now what do? We have a number with a variable and a number without a variable. What you're supposed to do is you will substitute the variable with the equation of the sum over here, and the number without a variable, you will put an n next to it. So what does this mean? This means it's gonna be what? 9 n over 2 times n plus 1, okay? Minus 2n. Okay, so now, what is the equation we have? We have 9 n over 2, n plus 1 minus 2n. Now let's go down. Again, what was our equation? 9 times n over 2, n plus 1 minus 2n. Okay, but how do they need it? If you look over here, you will see that they need n over 2 outside, and then it's b plus cn. What does this mean? This means we need to find n over 2 as a common factor. So we have n over 2 over here, but over here we don't have n over 2. So how do we find n over 2? From this, we need to do common denominator. In order for us to do common denominator, you will multiply up and down by 2. So this becomes 9n over 2, n plus 1 minus 4n over 2. You will take out the n over 2. After taking out the n over 2, you will be left with what? You will be left with 9 times n plus 1 minus 4. Okay? Now you are going to expand. So after expanding, it's going to be what? It's going to be n over 2 times 9n plus 9 minus 4. Now you will simplify n over 2 times 9n plus 5. Perfect. So we found our equation by using this method. If you guys want, I know you cannot message me right now, but I will do the other way, okay? So we found what our equation looks like. The value of b, which does not have n next to it, is 5, and then the value of c, which has n next to it, it is 9. So this is 5, and this is 9. Now, how to do it using the other way? We said the other way was n over 2 times 2a plus n minus 1 times d. Okay? But 2a1, my bad. So n over 2 times 2a1 plus n minus 1 times d. Okay? So what is a1? a1 in our case is 7. Okay? So a1, in our case, it is what? It is 7. And we don't need to find it because it's part of the equation. However, d, we need to find it. How do we find d? By doing, for example, next term minus the previous term. So we could take, for example, 25 and 16. You can do 25 minus 16. You will get that the common difference is what? The common difference is 9. So substitute it. It will be n over 2 times 2 times 7 plus n minus 1 times 9. Okay? Expand, so n over 2 times 14 plus 9n minus 9. Now simplify, you will get n over 2 times 9n plus 5. As you can see, it's the same exact answer. So these are two ways on how to do it. Okay, as you can see, by using both of the ways, you got the same answer. Now it says, based on your result of part A, what is the value of this sum? Very simply, what was our result in part A? It was n over 2 times 9n plus 5. So in order for us to be able to find the sum, you could do it like this, or you could do it in another way. What is the other way? The other way is you find the number n and you apply the equation n over 2 a1 plus an. Both ways work, so I will do both ways just to show you. Let us find n first of all. How do we find n? We apply the equation an is equal to a1 plus n minus 1 times d. Common difference is 9. So an, which is 358, is equal to a1 7 plus n minus 1 times 9. Move this to the other side. 358 minus 7 is 351. 351 is equal to n minus 1 times 9 divided by 9 is 39. So 39 is equal to n minus 1. N is equal to 40. Now that we have the value of n, we can substitute it in both equations. So it will become 40 over 2 times 9 times 40 plus 5. Okay, this is one way. Or 40 over 2 times a1, which is 7, plus an, which is 358. Do both of them on the calculator. 9 times 40 plus 5. Here you're supposed to get 7,300. Okay. And in the other way, if you do 40 over 2 times 7 plus 358, you will also get 7,300. So as you can see, both ways gave us the same answer, which is 7,300. Okay, so we finished from question number 11. Now we will move on to question number 12. Let A be an arithmetic progression with first term minus 5 and common difference 10. Okay, so let A be an arithmetic progression with first term 5, minus 5, and common difference 10, D is 10. Let B be another arithmetic progression with the first term 2, so A1 is 2 and common difference D is 9. So what is the equation? AN is equal to A1 plus N minus 1 times D. Okay, so substitute for both of them. It's gonna be minus 5 plus n minus 1 times d. For the other one, it's gonna be what? It's gonna be 2 plus n minus 1 times 9. And by the way, here I meant to put 10, not d. This is 10. Okay? They said, let m be the number for which am equals bm. That means there is a number in where the arithmetic progression of this will give us an answer, which is the same as the arithmetic progression of this. So how do we find out what this number is? Very simply, you have to make them equal to each other. So make them equal to each other. Minus 5 plus n minus 1 times 10 is equal to 2 plus n minus 1 times 9. Okay? Move this here and move that there. You will be left with n minus 1 times 10 minus n minus 1 times 9, which will give us what? Which will give us n minus 1. Okay? And then minus 5, move it to the other side. Minus 5 plus 2 will give us 7. So n minus 1 is equal to 7. Move minus 1 to the other side. N is equal to 8. Just like that, we found the value of n, which in this case is what? Which is m, which is 8. Now, what is the value of am? How do we find the value of am? Very simply, just take m, which we found to be 8, and substitute it in the equation a. So minus 5 plus 8 minus 1 times 10. You're supposed to get an answer of 65. Now, how do you double check this? Substitute it in the second equation. So 2 plus 8 minus 1 times 9. If you don't get 65 in this equation, then that means something is wrong. Or if you don't get the same answer, that means definitely something is wrong, because am is equal to bm. So if you substitute m in a, it's the same thing as substituting m in b. We move on to question number 13. Let b be an arithmetic progression with b4 equals 6, b6 equals 32, and b8 equals 58. What is the value of b5? How do we find the value of b5? Very simply, how I would like to do this, I don't know if it's a bit complicated, but what I'm gonna do is I'm gonna subtract these two digits, okay? And I will divide this difference by 2. Why? Because from b4 to b5, let's say you are adding x. And then from b5 to b6, you're adding x again. So x plus x is what? It's 2x. So that means 2x is equal to what is equal to the difference, 32 of b6 minus b4. So 2x is equal to, 2x is equal to b6 minus b4, right? b6 in this case is 32 minus b4, which is 6. You will get 26. That means the difference. So 26 is equal to 2x. That means the difference, x, is 26 divided by 2, which is 13. But we did not find b5 and we did not find b9. But very simply, what we can do now is we have the common difference d, which is 13. Very simply, b4. Add to it the common difference 13, you will get b5. So b5 is equal to 6 plus 13, which is 19. And for b9, it's the same thing. Just take b8, add to it 13, you will get the value of b9, which is what? Which is 71. So the answers are 19 and 71. We move on to question number 14. They said the first two terms of a geometric progression are 512 and 256 successively. We're dealing with geometric progression. That means whenever we deal with a geometric progression, we should have what? We should have a common ratio. So how do we find our common ratio? Usually it's second term divided by the first term, or next term divided by the previous term. So in this case, the next term or second term is 256 divided by the first term, which is 512. It will give us an answer of 1/2. Now, what does this mean? This means we will have to apply the equation of geometric progression. What is the equation of geometric progression? It is g1, the first term, multiplied by what? Multiplied by the common ratio r to the power of n minus 1. But as you can see, this is going to be a little bit confusing. So to prevent any confusion, what we're going to do is we're only going to multiply by 1/2 every time. So here you multiply by 1/2. We need to find what? The next 4 terms. So from here, we need to find 4 more terms. So multiply by 1/2. You will get what? You will get 128. Then multiply by 1/2. Again, you will get 64. Then multiply by 1/2 again. You will get 32. And then one last time, multiply by 1/2, you will get 16. So how many times did we do it? We did it 1, 2, 3, 4 times. That means we found the next 4 terms, which are consecutively 128, 64, 32, and 16. So 128, 64, 32, and 16. Okay, so now we move on to question number 15. It says G is a geometric progression with the first term G1 1/7 and common ratio R radical 7. Remember what we said, when we're dealing with a geometric progression, for any geometric progression, the basic equation is G1 times common ratio R to the power of n minus 1. So they want us to find what? They want us to find G4. Very simply, take G1, which is 1/7, times the common ratio, which is a radical 7 to the power of n minus 1, which is 4 minus 1, which is 3. Put it on your calculator and you're supposed to get an answer of radical 7. So very simply, here the answer is radical 7. They want G7, so again, you're going to take G1. G1 is 1/7, times the common ratio, which is radical 7, to the power of n minus 1. What is n in this case? 7, so 7 minus 1, that's going to give us a number of 6. So you will put it on your calculator and you're supposed to get an answer of 49. So very simply, our number over here is 49. We move on to question number 16. It says, consider the geometric progression 3 minus 9, 27, minus 81, 243. They told us what's the common ratio of this progression. How do we find it? You can take any term and the term before it and divide them very simply. So minus 9 divided by 3 will give us minus 3. Or 27 divided by minus 9 will give us minus 3. Or minus 81 divided by 27 will give us minus 3. As long as they are consecutive. Okay? And they give you the same ratio after dividing, then that means this is the common ratio, which is what? Which is minus 3. Now, what is the sum of the first 6 terms of the progression? Whenever we come across something like this, we will have to apply the equation of the sum. What's the equation of the sum? Very simply, it's g1 times 1 minus r to the power of n over 1 minus r. So g1, if you go up and see, it's going to be 3. So g1 for us is 3 times 1 minus the common ratio, which is minus 3. Please do not forget your brackets. This is very important. To the power of n, which is the term, which is the sixth term, over what? Over 1 minus the common ratio, which is minus 3. Put it on your calculator, and you're supposed to get an answer of minus 546. Okay, so our answer is supposed to be minus 546. All right, so minus 546. We move on to question number 17. Okay, this question is very easy. There's many ways to do it, but I'm just gonna give you the easiest, simplest way to do it. Take your calculator, okay? And look at your fraction, or not fraction, your number, your decimal. You have 0, right? So you're gonna put 0 point. Then you have 4, 5, and above the 4, 5, you have a line. What does this mean? This means that this is gonna be your repeating value. So for your repeating value, what you're gonna do is you're gonna put the repeating value multiple times on your calculator. So it's gonna be 0.454545454545. Keep on doing this until you don't see your 0 anymore. Then press equal, and it's supposed to give it's my bad, I lost my words. It's supposed to give you your answer, which is what? Which is 5/11. Same thing, we will do it for the for a similar question that will come up. So now we move on to question number 18. It says, what is the value of x? Okay, very simply, the numbers 96, x, and 6 are 3 consecutive members of a positive geometric progression. So how do we find the value of x? Very simply, what you need to do is we will need to find the common ratio. How do we find the common ratio? We said that it's the next term divided by the previous term, so it's 6 over x. Or it could be even the next term divided by the previous, which is x over 96. So 6 over x is equal to what? It's equal to x over 96. And they're both equal to what? They're both going to give us the common ratio r. So what we could do in this case is cross multiplication. Okay, so 6 times 96, that's 576. 576 is equal to x squared. So do radical 576. You will get what? You will get that x is equal to 24. So very simply, the value of x is what? The value of x is 24. Now, why did we not take minus 24? Because they said it's what? A positive geometric progression. What does this mean? This means that our common ratio is positive, and for our common ratio to be positive, both signs have to be the same. That means x and 96 have to have the same sign, or 6 and x have to have the same sign, which is positive. So in this case, it's going to be what? It's going to be positive 24 as our answer. So we move on to part B. What's the common ratio? So how do we find the common ratio? As we said, it's the term after divided by the term before. So next divided by previous. In this case, it's x over 96. We could take it, or we could even do 6 over x. But in both cases, it's going to be what? 24 over 96, which is equal to 6 over 24. And it's supposed to give us an answer of what? Of 1 over 4. So in all cases, the common ratio is what? The common ratio, oops, what did I do? Here, it is 1 over 4. We move on to the next question, which is question number 19. They said the sum to infinity of a geometric series if its first term is 48 and its second term is 36. How do we find the sum to infinity of a geometric series? Very simply, it's g1 divided by 1 minus the common ratio. So let's find the common ratio together. In this case, it's second term over first term, which is 36 over 48, which is 3 over 4. So now it's going to be g1, which is 48, over 1 minus the common ratio, which is 3 over 4. Put it on the calculator, and you will get your answer, which is the sum to infinity, which is 192. Notice, since the common ratio, the absolute value of the common ratio is less than 1, that means the sum to infinity converges. Okay, so very simply, in this case, our answer is 192. We move on to question number 20. What does it say? It says, find the sum of the first 40 terms of an arithmetic progression with the first term equal to 6 and the second term equal to 16. So what could we do in this case? Again, I personally like to use this method, n over 2 times a1 plus an. Okay, so n, in this case, which is 40 over 2 times a1, which is 6 plus an. So let us find an together. An is equal to a1, which is 6, plus n minus 1, so 40 minus 1, times the common difference. What's the common difference? It's 16 minus 6. Why? Because it's an arithmetic progression, which is 10. So put it on the calculator. 6 plus 40 minus 1 times 10 will give you an answer of 396. So 40 over 2, n over 2, times a1, which is 6, plus an, which is 396, it's supposed to give us an answer of... So 40 over 2 times 6 plus 396. It's supposed to give us an answer of 8040. So the sum of the first 40 terms of an arithmetic progression with whatever, it is what? It's 8040. We move on to the next question. Here, again, same thing as we did in question 18, I think. No, question 17. Same thing as we did in question 17. What you're going to do is you're going to take 1, and then you're going to put a decimal place. And as you can see, you have the line over 09. So on 09, you're going to be repeating the digits until you don't see it, until you don't see the 1 anymore. So it's going to be 09, 09, 09, 09, 0. So you just continue until you do not see the 1 point anymore. And then after that, you click equal, and you will get your fraction, which is what? Which is 12 over 11. We move on to question number 22. Okay, so given two complex numbers z, which is minus 4 plus 9i, and w, which is 5 minus 6i, we will need to fill in the blanks. Very simply, what I will do is I will do 2, and then I will open the brackets. 2 times minus 4 plus 9i, plus 4, open the brackets, 5 minus 6i, okay? So it becomes minus 8 plus 18i, plus 20 minus 24i. So minus 8 plus 20, this gives us an answer of 12. And then 18 minus 24i, this will give us an answer of minus 6i. So for part A, the answer is 12 plus minus 6i. For part B, we're going to do the same thing. So 5 times minus 4 plus 9i minus 5 minus 6i. So distribute minus 20 plus 45i minus 5 plus 6i. So after solving it, it's supposed to be what's minus 25 plus 51i. So very simply, we have it's minus 25 plus what? Plus 51i. We move on to the next question. Okay, here, this seems tricky, but it's actually very simple. What I would like to do in this case is divide it into two things. Real numbers and... I forgot how to write. Okay, real numbers and imaginary numbers. So what do we mean by real numbers and what do we mean by imaginary numbers? Real numbers is anything that does not have I next to it, and imaginary numbers is anything that has I next to it, very simply. So look what I'm going to do. I'm going to take the real numbers on their own. What are the real numbers? 7x and minus 21. And I will make it as if it was an equation by itself. So 7x is equal to minus 21. That means it's not I, my bad. Oops. Minus 21. That means x is equal to minus 3. And just like that, you found what? You found the value of x. Now we will take the imaginary numbers by themselves. So what's the imaginary numbers? It's minus 8yi, okay, is equal, do not forget, is equal to 4x minus 5yi. Now what do? We can cancel the I on both sides, and we will be left with minus 8y is equal to 4x minus 5y. We found x in the previous part. X is what? X is minus 3, so we can substitute it over here. Okay, move this to the other side, and you're going to get what? You're going to get... you're going to get minus 3y is equal to what? 4 times minus 3, which is minus 12. So then after dividing both sides by minus 3, you will get that y is equal to 4. So very simply, we have the value of x, which is minus 3, and the value of y, which is 4. So whenever you come across something like this, remember to separate the real numbers from the imaginary numbers. We move on to question number 24. Here we need to multiply two complex numbers together. So what do? Just multiply it as if it was a regular, two regular factors, you are multiplying them together. Okay, so 5 plus 4i times 2 minus I, we need to multiply them together. So what are we gonna do? We can distribute. So 5 times 2 is what? 5 times 2 is 10. Okay? Then 5 times minus I is what? It's minus 5i. And then 4i times 2, that is 8i. And then 4i times minus I, that's minus 4i squared. Now we will stop here for a second. We know that I is equal to what? It's equal to radical minus 1. So if we square it, I squared, it's the same as radical minus 1 squared. That means I squared is equal to minus 1. So we have the value of I squared, which is minus 1. It's a whole number, a rational number. It's not an imaginary number, it's a real number. So I squared is a real number, which is minus 1. Okay, so what does this mean? This means I can substitute the minus I instead of the I squared. So if you simplify everything, it's going to be 10 plus 3i minus 4i squared, but substitute the I squared by minus 1. So 10 plus 3i plus 4, so then it's going to be what? 14 plus 3i. So very simply, it's going to be what? It's going to be 14 plus 3i. We move on to question number 25. What does it say in question number 25? They said that the roots of this equation are this and this. How do we find the roots? For the people that have the option on the calculator, you can do mod 5, 3. For A, you will put 1. For B, you will put 6. And for C, you will put 25. Put it on the calculator, you will get two roots, which are what? Which are minus 3 plus 4i. And the second root, which is minus 3 minus 4i. For the people who do not have this option on your calculator, you will use the discriminant method. So delta, discriminant, is equal to b squared minus 4ac. Okay, b is what? B is 6. So 6 squared minus 4 times 1 times 25. Okay, put it on the calculator. 6 squared minus 4 times 1 times 25. It will give us an answer of minus 64. So now that we have the value of the discriminant, we can apply the rule of the roots. So roots are equal to what? Minus b plus or minus radical discriminant over 2a. Okay, so what is b in this case? B is 6, so it's going to be minus 6 plus or minus the radical minus 64 over 2a. A is 1, so it's basically 2. Now here we stop for a second. We have radical minus 64. This does not make sense to us. How does it work under the discriminant? So minus 64, we can separate it into two things, into 64 and minus 1. So we can take it as radical 64 and radical minus 1. We know radical minus 1, we can write it as I, and then radical 64, we can substitute it, we can make it 8. Okay, so now it's supposed to be minus 6 plus or minus radical 64, and then don't forget the I divided by 2. And now you're gonna substitute the radical 64 by 8. And now you're gonna simplify. So very simply, it's gonna be what? It's gonna be minus 3 plus or minus 4i. And we're back to where we started, which is what? Which is minus 3 plus 4i and minus 3 minus 4i. So minus 3 plus 4i and then minus 3 minus 4i. We move on to question number 26. It says, given 4x plus yi is equal to 16 plus 19i, where x and y are real numbers, and I is equal to radical minus 1, find the value of x and the value of y. So when you come across a question like this, what are we supposed to do? We said we'll separate it into two parts, the real part and the imaginary part. What is the real part in this case? The real part is 4x, so 4x is equal to the real part again, which is 16. So from both sides, you're supposed to take the real part, which is what? Which is the numbers that don't have I. So 4x is equal to 16. That means what? That means x is equal to 4. So very simply, we have the value of x, which is 4. Now for the imaginary part, take out the imaginary numbers. It's going to be x plus yi is equal to 19i. So now that you have the imaginary numbers next to each other, you have x plus yi is equal to 19i. So what are we going to do? We're going to cancel the I from both sides. And we'll be left with what? We'll be left with x plus y is equal to 19. And we found x previously. What is x previously? It is 4. So very simply substitute the x by 4. So 4 plus y is equal to 19. Move 4 to the other side. Y is equal to 15. So very simply, we found the value of x and we found the value of y. X is equal to 4 and y is equal to 15. So x is equal to 4 and y is equal to 15. Perfect. Now we will move on to question number 27. What does it say in question number 27? So they told us the expression 121x squared plus 9 can be factored over the set of complex numbers as whatever this is. So for the people who have a calculator, of course, you can go and you can do mode 5, 3. You can put for A 121, you can put for B 0, and you can put for C what? You can put for C 9. And you will get what? You will get two factors or two roots. You have root 1, which is what? 3 over 11i. And then you have what? You have root 2, which is what? Which is 3 minus 3 over 11i. Okay, move 11 from both sides. You're going to get 11x is equal to 3i and 11x is equal to minus 3i. And now you will move both sides to get the two factors, which is what? Which is 11x minus 3i and then 11x plus 3i. Okay, this is one way of doing it. Now, another way of doing it is by factorizing. Look over here. Can you take anything out? For sure you cannot, because there's no common between 121 and 9. But however, what you do notice is that it looks like what? It looks like the difference of two squares. It looks like the dots. However, the only difference that we have is the plus sign. So what I will do in this case, what you should do in this case, what we should do in this case is you will take the plus sign and you will think of it as if it's minus. And you will treat it as if it's the difference of two squares. Now you will take it. If you were to factorize this as if it were the difference of two squares, it's supposed to be 11x minus 3 and then 11x plus 3. Now this is what? We're imagining that it's minus, but let's go back to reality. Let's say, okay, there's no minus, it's a plus. What do we do in this case? In this case, next to the number, next to the constant number or the number without a variable, we will put an I next to it. Okay, so 11x minus 3i and 11x plus 3i. 11x minus 3i, 11x plus 3i. We move on to the next question, which is question number 28. They want to find z plus w. Very simply, z is what? It's 8 plus 4i plus w, which is minus 1 plus 22i. All you need to do is add them. 8 plus minus 1, that's 7. And 4i plus 22i, that's 26i. So very simply, 7 plus 26i. We move on to question number 29. What does it say? It says they want us to multiply z and w. So we're going to do it again. This time it's going to be 8 plus 4i multiplied by 5 plus 2i. And now you're going to play the distributive property. So what is the distributive property? That means it's 8 times 5, which is 40. And then 8 times 2i. What's 8 times 2i? That is 16i. And then we move on to 4i. So 4i times 5, that is what? That is 20i. And then 4i times 2i, that is what? That is 8i squared. Now we stop for a second. We know that I is a radical minus 1. That means I squared, it is what? It is minus 1. Minus 1 is a real number. It's a number that will not make our heads go crazy. It's an actual number that we can use in this equation. So what are we going to do in this case? You're going to substitute the I squared by minus 1. So it becomes 40 plus 36i plus 8 times minus 1. So 40 plus 8 minus 1, that's 40 minus 8, which is 32. So 32 plus 36i, and this is what? This is the final answer of z times w. So 32 plus 36i. Now we move on to question number 30. Okay, so here they want us to find the roots. For the people that have the option on the calculator, you can do mode 5, 3, and you can put for A 1, for B minus 4, and for C 13. Just put it on the calculator. You will get what? You will get 2 plus 3i and 2 minus 3i. Just like that, you have your roots. But for the people who don't have the calculator, you will need to find the discriminant. So discriminant is b squared minus 4ac. So b in this case is minus 4. So minus 4 squared minus 4 times 1 times 13. Put it on the calculator. Minus 4 squared minus 4 times 1 times 13. You will get an answer of minus 36. Okay, so now we will need to put it in the equation of the roots, which is minus b plus or minus radical discriminant over 2a. We have b in this case, which is minus 4. So minus 4, it will give us 4 as an answer. Plus or minus radical discriminant, which is minus 36 over 2a. So 2 times 1, which is 2. Now, notice, we cannot deal with minus 36. It does not make sense. Radical minus 36 does not make sense. So what we will do is we will separate it into two values, which is 36 and minus 1. Radical minus 1, you can replace it as I, and radical 36, you will put 6 as an answer. Okay, so 4 plus or minus radical 36, which is 6, and then radical minus 1, which is I, over 2. Now, after simplifying, you're going to get your final answer, which is what? Which is 2 plus or minus 3i. Okay, so very simply, our equation, or not our equation, sorry, our roots are what they are. 2 plus or minus 3i. Now we'll move on to the final question. Finally, the final question of the last math AMS of grade 10, which is what? Which is minus 3 plus 2i. Multiplied by 5 minus 9i. So here you're just going to multiply it normally. So minus 3 times 5, that's minus 15. Minus 3 times minus 9i, that's going to be plus 27i. Plus 2i times 5, that's going to be plus 10i. Now, very important, plus 2i times minus 9i, that's minus 18i squared. Remember, I squared is equal to minus 1. Minus 1 is a real number, and we can substitute it instead of the I squared. So minus 18 times minus 1, that's going to give us plus 18. So now, minus 15 plus 27i plus 10i plus 18. After simplifying, it's going to be what? It's going to be 3 plus 37i. So 3 plus 37i. Let us submit, and I'm praying because I've been like almost an hour here. We don't have any mistakes, and perfect. Thank God we do not have any mistakes. 80 minutes, that's crazy. Thank you guys for watching. I hope you enjoyed and have a wonderful day. And thank you so much for staying with me until the end of the year, which is the term 3 final math AMS. So I hope you guys enjoyed grade 10, and I wish the best upon you all. So have a wonderful day, have a wonderful year, and I will see you in the next video.